So 1.3, the second part, we're going to start by evaluating equations. Now, we're going to talk about some piecewise equations. Piecewise means simply this. It has two different sections to it with different requirements, okay? And so that means my graph is going to be broken up. Like one graph will go this way and one would go this way or something like that. So if I graphed it on a number line, you have piecewise functions on number lines where like you do something like this and then over here it goes this way, okay? But this time it's going to be like on a actual XY axis plane. The first part is just evaluating when x is -1, 0, and 1. And your piecewise function says f of x equals x squared plus 1 and x must be less than 0. And then f of x equals x minus 1 when x is greater than or equal to 0. So to solve these or to do this, you literally just have to follow the parameters they have. In this equation, what is the only thing I can plug in? What is my parameter? Anything less than 0. So the only thing I can plug in there is -1. So we're going to plug -1 in to this first equation, and that's all. So -1 squared plus 1, which gives you 2. Okay? That's evaluating. Now, this one down here says x is greater than or equal to 0, yes?
Yes, ma'am.
Okay, so that means I can plug both of these into that equation. So I have to plug 2 into this one. So first I'm going to say 0, I'm just going to say x minus 1. So I have 0 minus 1, which equals -1, okay? And then I have x minus 1. And I plug in 1, so I have 1 minus 1, which equals 0, okay? So when it says evaluate for those, that's what you're simply doing, okay? You're evaluating. If you go to plug these into your graph, in calculator to graph it, if I can speak that would help. We're going to talk about how you do it, yes, because eventually we're going to have to, so let's talk about it, okay? When I go to plug these in, you're going to take this first one and you're going to plug it in where it says y1. And you need to put parentheses around this because we're going to plug it in as an equation so that we can solve. So let's practice this real quick.
So we put the...
You go to y1
Okay.
and you are going to put parentheses and you put x squared plus 1 in parentheses. But then you're going to have a second set of parentheses, okay? And it's what your parameter is. X is less than 0, okay? So here's the deal. Let me tell you how you get that less than sign. So I put parentheses, x squared plus 1 in parentheses, okay? And then I put parentheses, x less than 0. To get to less than, you have to go to, I've got to think about it for a second. You have to go to second math, okay? Because if you press second math, it says test above it. That's what you want to hit. When you go to test, it's going to give you equals, it's going to give you not equals to, greater than, less than or equal to, greater than or equal to, okay? And then you choose the symbol that we need. We need less than, yes? Okay, so go down to less than, which is number 5. And I would plug that in. So I have x squared plus 1, and then I have x, and I have less than 0. Okay? Then I go down to the second y2. Okay, this is y2. And I plug in parentheses x minus 1, and then parentheses x greater than or equal to 0. Okay? X minus 1. And then I get the greater than or equal to also in the same spot. Second math. Go down to greater than or equal to. And when I graph these, I'm going to assume that my viewing window probably needs to be set to standard form, which is -10, 10, 1, -10, 10, 1. Yes, sir?
I have that in business.
And what?
My window is what you have, but I can't even see.
Give me a second, let me see.
I can just, but.
Here, negative 10, 10, 1, negative 10, 10.
Oh, 10. Oh, I like that bit.
Okay, and you're going to get two little graphs where they do not connect or do not touch. It looks something along these lines. The one is at 1 and it curves this way, okay? And the one is at negative 1 and it goes like this, yes?
Yes.
Those are piecewise functions, okay? That is how you graph piecewise functions. You put the equation in parentheses, you put the parameter in parentheses, okay? And then it makes it so much easier than us trying to graph it by hand, okay? So when you see piecewise functions, when you are evaluating them, you only plug the ones into where the parameter works and you get answers. And then when you are graphing it, you put everything in parentheses so that you can graph, okay? It's really not that difficult, you just have to remember where to find those buttons, okay? Questions? Any questions on that so far?
What is the arrow? Like X squared plus
Oh,
what do we do for that?
what is the arrow? What do you
Yeah,
mean?
where it says X squared plus 1 and there's an arrow?
This?
No, down front.
Oh, I was just plugging this in.
Oh.
I was just giving equations. Okay? The next thing we need to talk about today is domains, finding domains in different scenarios, which we've done prior to this. Okay? If they give you a list of numbers, what are the domains? Your x's. So what is my domain on this right here? Negative 3, negative 1, 0, 2, 4. Okay? That's an easy one. If they give you a list, you just take all the x's. Okay? What is the domain of g of x equals negative 3x squared plus 4x plus 5? What numbers can you plug in to get outputs?
Plug in.
This one always tricks people for some reason. This should be the easiest one. Okay, I can, yeah, so, can you plug negatives into that equation and get outputs? So what would that be? All real numbers. Oh, okay. All real numbers. Anytime your equation, okay, does not have a fraction or is not a radical, it's all real numbers. Okay? Now, with fractions, what do I have to do to figure out what my domain is? Because a lot of you missed this on your last test, and we're going over it again, you're not paying attention. How do I figure out domain for fractions?
Don't you have to set it equal to 0?
Set what equals to 0? Yeah, the bottom. So I say x plus 5 equals 0, which means x cannot equal what? Negative 5. So it's all numbers except negative 5. If you write it that way, it's fine.
So if you just write, because on the test I would have the right number, but I wouldn't say it the right way. So it matters about how the right way you write it.
Correct. Okay. So that is for fractions. And then if you have radicals, remember you have to take what's inside the radicals, set it equal to 0, and you make an inequality out of those. Okay? You can't leave it as not equal to this. It's either like greater than 12 or less than or equal to 12, something like that. Okay. Now they're going to make us find domains of equations that they just give us. How do I find the domain of this volume equation? How do you find the domain? What would be the domain of that equation?
I have no clue how to do that.
Well, what can you plug into R? First of all, this is the volume of a sphere, okay? So let's recognize that. What shape is a sphere like? A circle. So what numbers can you not have in a circle? Negative. So what would be my domain?
X is greater.
X is what?
Greater than 0. Greater than or equal to 0.
Greater than or equal to 0, yeah. X would have to be greater than 0. Because your radius can't be 0 either in a circle, yes? So X would be greater than 0. Domain, okay? So they can give you domains or ask for domains of any other equation too. And what you're looking for is where the variable is, what can you plug into it to make it a true statement, okay? How do I find domain of this? 4 minus 3x in the radical. What do I have to do there? Well, sort of, Betty. A not equal to 0, what did I say you have to use in radicals? not an equal sign, it's,
It's,
yeah.
what's that? It's greater than.
An equality,
Yes.
an equality
Would it be
sign.
like,
So I'm gonna say to this, 4 minus 3x, and then you're going to have to put it in greater than or equal to 0, okay? Because you can only have things inside a radical that is greater than or equal to 0. So anytime it's a radical, you put it greater than or equal to. And you stop from here, you subtract 4, okay? 3x is greater than or equal to negative 4, or negative 3x, divide by negative 3, and x is greater than or equal to 4/30. And that is your domain of that one, okay? You always set it greater than or equal to 0, because you can't have negative numbers in radicals, because that means I have imaginary numbers, and we don't want to deal with those, okay? Next thing, let's say that you are given, I'm going to read you a word problem in a second, but I'm going to give you some equations that go with it. Okay, this says n of t, and it is a piecewise function. Why is there so much talking? You are annoying me. I'm starting to get angry. Pay attention. I've seen all of your tests and your test corrections. Or, I'm sorry, I haven't seen your test corrections because you didn't turn them in. So,
That was directed at somebody.
pay attention, okay? So if they give us equations like this, okay, piecewise equations, that means I've got to pay attention to the parameters of what is happening. And the equation says, or the word problem says, the number in thousands of employees in the interior design service industry in the United States decreased in a linear pattern from 2007 to 2010. Okay? In 2011, the number rose and increased through 2012 in a different linear pattern. So this is the decrease, this portion is here, and this would be a different pattern that started to increase. Does that make sense? So if I graphed those in my graphing calculator, one would be decreasing and then they'd break away, and the next one would be increasing. Okay? And it says these two patterns can be approximated by the function, where t represents the year with t equals 7 corresponding to 2007. Use this function to approximate the number of employees for the years 2007 and 2011. What do you think we need to do to approximate 2007 and 2011? What do we need to do? No, we don't have, we can do it all on our graphing calculator. I can't talk. Okay, so let's plug this piece and this piece into our graphing calculator, and this piece and this piece. What do you have to do when you're plugging those in again? Parentheses around them. So negative 4.64x, okay, plus 76.2 in parentheses, and then the second one should be 7, and then you're going to have to go into that second math twice because it's a less than or equal to and a less than or equal to. And it's less than or equal to 10, and you're going to put in parentheses. Then I'm clearing the second row and I'm putting 0.90x plus 20, and then I'm putting 11 greater than or equal to. I'm sorry, less. Does it matter what order you put them in?
Like, say I put the 7 is less than or equal to t first.
Before the negative.
You mean before this?
Yeah.
Yes, you need to put this in and then this in. Because it has to have the equation and then it can do the parameters.
How do you do the arrow?
You press second math. Okay? So if I plug those in and I press graph, I'm gonna need to change my window. That goes up to 7, that's 76, that's negative 4. So your x, negative 10. Count by 2. Okay, I just roughly put in a different window just for the heck of it. I've made it a minimum of, let's do -20, and let's go to 100, and let's count by like 4s or something like that.
I didn't even graph.
Because you need to change your window. Because it won't read it because it's too large.
So then what's
I made my windows, see how this is 76 right there? So I have to go above that. Okay, that's a y-intercept right
Go
there.
to 80.
So I went to 100, just to play it safe, but that's a y-intercept, yes? So I just made my x and my y's the same. I did -20 for my x min, 100 for my x max, and I counted by 4s, so that it wouldn't be like so scrunched on top of each other, I could see it better. And I did the same thing for my y, and I ended up getting 2 lines, okay? Now, it wants to know, in 2007, what was the output? In 2011, what was the output? How did I show you to do that before? How do you figure out?
You have to press second graph.
Press,
Table.
yeah, well, you can do it that way, you are correct. Or I can do it in an even quicker way by pressing, let me think here. Give me a second. By pressing second trace, and you can figure out what the value of something is and plug it straight into X. So if I want to figure out what X is in 2007, 7 representing that, I press 7 and enter, and it will tell me 43.72, okay? Which means it was 43.72 in thousands, right? And if you press second and trace again, which is calculate, and press value again, and I want it in 11, if I press 11 and enter, you're gonna get 25.16. Okay? So you have, and this is in thousands of employees. Okay? So in this year, you had around 43.72 thousand. Okay, you just would change it to thousands, and you have 25.16 thousand.
Is it the same for either way you press Y trace? I mean, second trace or second graph, does the same stuff come up?
If you press second and graph, the same stuff comes up, you just have to scroll through that whole table down to the numbers you wanna see. You know what I'm saying? Does that make sense? If you press second trace, the value takes you exactly to where that point is that you press.
I'm asking because I'm plugging in the right numbers, but I'm not getting what you're getting.
Yes, you are. You're just, you have 2 tables, don't you?
Well, they press Y trace.
And if you go,
I don't know. I'm getting 107.
I get the same thing either way. You're getting a different thing, because this line is not being graphed right.
We got the,
Something is wrong. Oh, here's what's wrong.
no, you didn't get the
You
pro
see in
or
your
the.
equation, you said negative 4.64, what's missing from there?
That's the one you got. Looks like
Yep. That's why it's true now. Okay, so that's how we're going to solve some of these word problems tonight. You're gonna graph them on your graphing calculator and then just read the graph from there.
Okay.
And then one last thing that we need to look at, and then we will do some homework. Morgan, you got a question? Okay, last thing is we wanna find the difference of quotients. Okay? And this is gonna be a little tricky, I'm not gonna lie. Okay, so let's say you have f of x equals x squared minus 4x plus 7. And they want you to find, okay, f of x plus h minus f of x over h. Okay? Now, here's the deal. One of the basic, things in calculus is the employees is the ratio. And you have this, it's called the difference quotient, okay? The difference quotient has a standard formula, and it is f of x plus h minus f of x, okay, over h, where h cannot equal 0. So this right here that we're trying to find is called the difference quotient, okay? What does quotient mean?
Alright, so.
Divide. So we're trying to find the difference quotient of this formula, okay? In order to do that, we have to do a lot of substitution and fun stuff like that, okay? So because this says f of x equals x squared minus 4x plus 7, that means anywhere that there's an x, I am plugging what into it? Anywhere there's an x, I'm going to plug in what goes with it, okay? Which is, in this case, f of x and f of x plus h are the same thing. I'm going to plug them in together. So when I want to solve this, okay, when I want to find the difference quotient, I have to plug fun things in. So I get this. You get f of x plus h, okay, minus f of x over h equals. And now I'm plugging this equation into the x's, okay? X plus h squared, okay, because this is squared, so that becomes squared, okay? Minus 4 times x plus h, because I plugged that in again to the x, okay, and the 4 was there. And then you have plus 7, okay? Minus x squared minus 4x plus 7, because here's what we did, all over h, okay? So here's what I did. You first have to work with this portion of the equation and plug everything in. So x plus h goes anywhere there's an x in this equation. X plus h squared minus 4x plus h plus 7. Then you have to come over to the minus f of x, and you have to plug this in anywhere there's an equation. So that whole equation just drops down, okay? And it's all over h. Now, what do we do from there?
You have to solve.
By doing what?
Substitute.
I'm not substituting anything.
Distribute.
I need to distribute this negative into all of this, and they combine like terms. I need to multiply x plus h and x plus h together, yes? Okay, so there's a lot of little things I have to do. When you do this, it's actually saying this. So what happens when I do this? X times x is, and then I get xh, and I get xh, so I get 2xh, and then I get h squared, yes? Okay, here, you get negative 4x minus 4h plus 7, yes? And here you get negative x squared plus 4x minus 7, correct?
Yeah.
Now I combine all those like terms on top, okay? Now, x squared, negative x squared, they cancel, okay? I only have 2xh, so I'm going to have 2xh. I only have an h squared, right?
You
Yeah.
have 1 squared.
These cancel though, the 4x's. So I have an h squared, I have minus 4h, I have plus h squared, and you have
And you have the 7.
the 7 and the negative 7 cancel.
Minus x
Okay.
squared plus 4.
So you're left with that all
It's
over
still over h, right?
h. Yep. Now, what can you factor out of here?
H.
An h. Okay? If I factor an h out, I get
H parentheses
2x minus 4 plus h over h. What happens there?
2x plus
The h's cancel.
minus 4.
Okay? And you get 2x minus 4 plus h, where x cannot equal
0.
0. Or h, I should say, because that's what we got rid of. H cannot equal 0. And that is what they want you to do. You're plugging an equation into another equation and simplifying. Okay? That can get messy and a little bit confusing. Okay? That is what we're doing tonight, all of that stuff, piecewise functions, all that fun stuff.
It's a lot of